If you've not done so already, change your directory so you're in the SVN Guru working copy area. And the first thing we'll do is check out a fresh working copy. We'll do this with the svn checkout command. And we'll create a directory called mo3lo5, which will be mapped to the trunk directory within the mo3lo5 directory. Once you've got that checked out, then change your directory so that your current directory is the root of this working copy. We're now ready to perform some basic edits. Let's take a look at the contents of our working copy. We've got a very simple working copy here, and the file that we're really interested in is file1.txt. Let's take a look at the status, and you'll notice that there's no status changes locally, which is what we'd expect from a freshly checked out working copy. The status -u lets us know whether anyone has, for example, committed new changes into the working copy, and this in turn will keep us informed about any potential problems when we next do an update. We'll take a look at all of these kind of issues when we look at the developer lifecycle later on. Okay, let's edit file1.txt. I'm using Notepad here just because it's generally available, but you can use any text editor that you prefer. We'll just make a couple of trivial edits and then save the file. So we now have a modified file1.txt in our working copy, and we can show this by running the svn status command. The status command shows an M next to the file1.txt, indicating that the file1.txt has been modified in this working copy. Repeating the status command with the -u option adds the information that the file1.txt was originally revision 1. So what we're being told by this command is that file1.txt was in the working copy originally as revision 1, taken from the repository, but we've subsequently modified it as indicated by the M in the first column. We can get further information about file1.txt by using the info command. Most of this is exactly what you'd expect. The last changed author and last changed revision are information that's come from the repository. So the last changed information doesn't indicate anything about the change we've made to the file. It indicates the last changed information taken from the repository. So it's informing us that revision 1 was actually created by the owner and that it was created on the 3rd of August. However, the text last updated field is telling us that there was a subsequent change. The last change made in the repository was made on the 3rd of August at about 4:15. The text in the file was last changed at 5:42, and this shows the edit that we actually did in the working copy. So far, all the modifications have been made on the local file system, in other words, in our local working copy. So as you can see on the right in the orange working copy area, the file1.txt at the bottom of the display shows an M for modified. This matches the status indicator returned by the svn status command. Nothing else has changed. The repository remains at revision 1 because we've not made any changes to the repository. And everything else within the working copy remains at revision 1 because we've not made any changes to those either. In order to make this change effective within the repository, we need to use the commit command. The commit command commits any changes within our working copy into the repository. Issuing this command at the root of the working copy, which is where our current working directory is, means that any changes within the working copy will be committed into the repository. Whenever we commit something into the repository, Subversion will request that we add a message to be associated with the revision. This message should tell us something about what we've done to the file or files that are committed in this operation. In this case, I'm using the -m option, which is the short form of --message. The -m option expects a string argument, and this string will be used as the log message to be associated with the revision. When the commit command is executed, the Subversion client will scan the working copy looking for any status changes, and will commit those status changes back into the repository. In this case, file1.txt has been modified, so it sends the file1.txt to the repository and records this as revision number 2 within the repository. So the commit operation commits revision number 2. It creates a new revision within the repository. The new file is written into the repository to be recorded for posterity, and the working copy is updated to reflect that the new revision has been created. Using the info command, we can confirm what's happened to file1.txt. We can see that the revision is recorded as revision 2. This means that our working copy file1.txt is synchronized with revision 2 of the repository. The last change revision is also revision 2, which makes perfect sense since we've just committed it back to the repository. We can also see that the last change date is the 3rd of August at about 5:44 in the afternoon. The text last changed is 5:43, in other words slightly earlier. This is exactly what we'd expect since we modified the text and then we committed it, and the last change date is the date on which we actually committed revision number 2. We can also use the svn log command to look at the history. It might be tempting to think that the svn log command issued at the root of the working copy would provide us with the log of all operations that have taken place in that working copy. However, that's not what actually happens. If we run the log command, you'll notice that revision 1 is reported. So what happened to revision 2? To understand what's happened, you have to understand that the svn log command is implicitly asking for the log of the current working directory. Since the current working directory, the svn guru wc mo3 lo5 directory, is still synchronized with revision 1, when we issue the svn log command, we receive only a report for revision 1. We can confirm this using the info command. If you do an svn info, again, it implicitly takes the path dot or current working directory. Since we haven't updated the current working directory, we've only committed the file1.txt change, the current working directory remains synchronized to revision 1. Since the current working directory is synchronized to revision 1, the log command only reports revision 1. If, however, we explicitly request the log of file1.txt, we get revision 2 and revision 1 as we would expect. Looking again at our working copy, you can see that file1.txt is in fact synchronized with revision 2 in the repository. So when we ask for the log of file1.txt, we see revision 2 and revision 1. If we look at the status of the working copy, we get a blank line, reporting that there are no outstanding operations in this working copy, which is what we'd expect. We've only just committed the file1.txt, which was the only modification that we'd made in the working copy. This is something that often confuses new users to Subversion. The commit command will only commit the modifications that were scheduled against the working copy, in this case file1.txt. The commit command does not do an implicit update on the current working directory as a whole. Since it doesn't do an implicit update on the working copy as a whole, the root of the working copy remains synchronized with revision 1 of the repository. So as you can see in the illustration on the right, the root directory, the mo3 lo5 directory, remains synchronized with revision 1 of the repository, despite the fact that if you look at the repository, there is actually a revision 2 of the trunk. This revision 2 of the trunk was created at the same time as we committed the file1.txt. We'll see later in the course, when we discuss doing updates, how this all comes together. But for now, the main thing to understand is that Subversion does not do anything unless you explicitly request it. So the commit instructs the Subversion client to commit the modifications that have been made in the working copy to the repository. It does not say anything about updating the current working copy to match what's in the repository. So the only things that will match after a commit are either those things which have not changed in the repository or those things that have actually been committed.